Welcome to Climate Reflections, the SRM 360 podcast, where we discuss sunlight reflection methods, or SRM, ideas to reduce the impacts of climate change by reflecting sunlight away from the Earth. I'm your host, Dr. Pete Irvin, and I'm a climate scientist who has studied SRM since 2009. In 2024, the Advanced Research and Invention Agency, or ARIA, a UK government-funded initiative, put out a call for proposals to explore climate interventions aimed at lowering global temperatures. In May 2025, ARIA announced its initial round of awards for their Exploring Climate Cooling program. The program will ultimately dedicate £56.8 million to support solar geoengineering research. This will make ARIA the largest single funder of solar geoengineering to date, according to our new analysis of funding for the field, which you can find at srm360.org. Not only is ARIA the largest funding effort, it is also supporting multiple outdoor field experiments. One focused on thickening sea ice in the Arctic, 3 that will test technology and concepts related to cloud brightening, and 1 evaluating potential particles for stratospheric aerosol injection. The inclusion of these outdoor field experiments in the funding call raised eyebrows even before the funded projects were announced. In March 2025, Michael Mann and Raymond Pierre Humbert, 2 prominent climate scientists and signatories to the Solar Geoengineering Non-Use Agreement, published an opinion piece in The Guardian criticizing ARIA for funding solar geoengineering research at all, and especially for funding outdoor experiments. The pair cautioned, quote, "There is extreme danger in launching such field trials into an environment with neither national nor international governance in place," end quote, and emphasized the potential dangers of legitimizing SRM research when emission cuts are the key to solving the climate crisis. So today's episode explores this idea of SRM field experiments. What experiments are already happening, and what impact could they have on the environment? What can we learn from outdoor experiments that cannot be discovered in other ways, and should outdoor SRM experiments require special kinds of governance? This episode also anticipates a new tool we're adding to the SRM 360 website, the SRM Field Activity Tracker. This tracker will be an interactive online tool you can use to find out what SRM field experiments and other activities are happening or planned, and to learn more about them. For today's episode, we spoke with scientists engaged in outdoor experiments and to governance experts with insight into best practices for these controversial field activities. In an upcoming episode, we'll dive even further into the realm of research governance. Let's start with the basics. What is an outdoor field experiment?
It's a good question, and I think it's especially fraught here because it's completely vague.
That's David Keith, Professor of Geophysical Sciences at the University of Chicago and Faculty Director of the Climate Systems Engineering Initiative, or CSEI, an interdisciplinary academic research cluster focused on climate interventions. It should be noted that I work at CSEI as a research assistant professor. Here's more from David.
But to me, it's something that is an outdoor experiment in environmental science designed to answer some scientific question. And any such experiment has some environmental harm because you're doing something in the environment.
If there is potential for environmental harm, why would any scientist conduct field experiments? Well, field experiments can offer unique insights that can't be obtained from computer or lab-based studies. Let's hear from 2 scientists who are involved in outdoor field experiments. First, John Moore, glaciologist and research professor at University of Lapland in Finland. He also leads the thematic network on frozen Arctic conservation for the University of the Arctic.
So in the laboratory, you are constrained within a few square meters, perhaps 10 square meters pretty much at the most. And there's no weather. There are no currents moving the waters around. There's not even any people that are driving snow scooters or fishing or just animals. Everything is absent from a cold room. So if you go out into the field, you can actually see what ice is behaving like in the real world, and especially if you change the type of the ice or add more ice, and therefore if it's done what you want it to do, it will extend its life further into the spring. The sun is higher in the sky, the radiation patterns and the wind currents will be different from it in the middle of the winter or whenever the ice would normally be breaking up.
John has done fieldwork on glaciers, both observational and some experimental interventions, testing different methods that might preserve ice, but he's not done SRM-related outdoor experiments. Our next guest, Dr. Daniel Harrison, is an associate professor in the National Marine Science Centre at the Southern Cross University in Australia. Daniel leads the Cooling and Shading subprogram of the Reef Restoration and Adaptation Program, RRAP, which includes outdoor marine cloud brightening experiments.
So the field experiments have been absolutely essential. The very initial feasibility modeling was desktop and numerical modeling type studies, but where that really falls short is probably mainly across two areas. One is the technology development. You can do all the desktop work in the world, but until you're actually building prototype devices, you don't start to unravel, identify what the real technical challenges are of operating these, how they perform in the real world, how do you make them robust, how do you make them safe to operate, and then the other aspect is really the modeling. You can't trust it too much, in my opinion, if it's not validated against real field data, and the amount that we've learned by going out into the field is just incredible.
Researchers consider field experiments to be a valuable contribution to addressing some questions in Earth system sciences. Nonetheless, there have not been very many SRM-focused field experiments to date, and several have been cancelled. Here I'll give a quick overview of the ones which went ahead. The earliest series of outdoor SRM experiments took place in Russia from 2008 to 2010. A team of scientists led by Yuri Israel of the Institute of Global Climate and Ecology, Roshydromet, and Russian Academy of Sciences in Moscow generated aerosol particles in the lower atmosphere from a truck and from a helicopter and measured the impact those aerosol particles had on the amount of sunlight that reached the surface. The Russian experiments had implications for stratospheric aerosol injection, the most well-studied SRM idea. In July and August 2011, a group of US-based scientists completed the E-Piece experiment, which used a ship and a plane to add controlled amounts of aerosol particles to the atmosphere and measure the response of clouds. The group also measured the impacts of cargo ships passing through the study area. This was not explicitly an SRM experiment. The group was generally interested in measuring cloud-aerosol interactions, a major source of uncertainty in atmospheric science. But the study has implications for marine cloud brightening. The Reef Restoration and Adaptation Program, the ongoing study in Australia led by our guest Daniel Harrison, has emitted aerosol particles over the ocean on and off since 2020 to understand the potential for marine cloud brightening to help cool the reef. There have been a couple other outdoor activities that have occurred at smaller scales. In 2022, Andrew Lockley, at the time a researcher at University College London, launched a single balloon that released about 400 grams of sulfur dioxide to the stratosphere. The balloon system was assembled from relatively inexpensive hobbyist parts and served as a, quote, engineering proof of concept, end quote. Lockley gave the project the provocative title, the Stratospheric Aerosol Transport and Nucleation, or SATAN experiment. Some of the researchers questioned whether Lockley's project had scientific or engineering merit beyond highlighting the need for SRM governance. And a small US-based startup called Make Sunsets has gotten substantial attention in the press and from the US Environmental Protection Agency, the EPA, for their small balloon launches of sulfur dioxide. These launches aren't done with specific scientific or engineering questions in mind, so they don't really fit the definition of experiments. Instead, the company sells shares of their launches as unverified cooling credits and has the goal of cooling the planet right now. While all of these efforts went ahead, several others were cancelled after public or activist opposition or other issues arose. The controversy around these efforts and concerns about the direction of this research has inspired calls for governance, specifically for SRM field experiments or SRM research more broadly. But are SRM experiments inherently different from other environmental field experiments? Here's David Keith.
Of course, field experiments aren't unique to solar geoengineering. Field experiments, including field experiments that are manipulative, that do something to the environment, are a mainstay of environmental research. You can think of thousands of examples from experiments literally in fields that put ozone, a pollutant, into the atmosphere to look at how crops react, or CO2 to look at how crops react, or NOx.
When David says NOx, he is talking about nitrogen oxides, a group of air pollutants that contribute to smog and acid rain and cause respiratory problems.
This is how you do environmental science. And to be clear, all these things should be and are regulated. Field experiments, including ones that have environmental impacts, are a mainstay of environmental science. And I do not believe that environmental science should just freely be able to do whatever they like outside. There need to be checks and balances. My view is those checks and balances in an appropriate system of good governance and democracy should be not much related to the specifics of the science, but should be based on the environmental risks.
Glaciologist John Moore provides his perspective.
solar geoengineering trials should be treated in the same kind of way as most other sorts of large scale or small scale outdoor experiments that people do. So beyond a certain scale, people have to do an environmental impact assessment of what is happening. People use the precautionary principle. I think this is a very, very key principle that says you will never have perfect knowledge of what are the results of both of doing something and of not doing something. You make a decision based on the best available knowledge at the time that the decision is needed. So that, I think, is something that should be applied in just the same way to solar geoengineering experiments as any other kind of experiments. And if you think about stuff like the land surface, what humanity has done almost without a second thought, changing the forests and building farms and agriculture, introducing different kinds of plants and animal species there. And there's essentially not been any regulation for that. So it's very hard for me to understand why we would want to do this in a different way, as long as we follow established protocols like the precautionary approach.
Many attempts at outdoor experimentation related to SRM have met with resistance from local residents and activists from around the world who object to the study of SRM on principle rather than to the specific risks posed by the proposed field experiment. Our guest Daniel Harrison engages in experiments that have implications for marine cloud brightening. Does he consider these experiments to be SRM or solar geoengineering experiments? Here's Daniel again.
I'm not sure that in our case we're sure it is geoengineering because we're not interested in trying to change the temperature of the planet. We're interested in trying to intermittently cool down an ecosystem to relieve acute heat stress events, in this case on the Great Barrier Reef. What motivated us to start was the mass bleaching events that occurred in the summer of 2015, 2016 here in Australia. Prior to that, there'd been some historical bleaching on the Great Barrier Reef during previous El Ninos, but it was relatively sort of minor to moderate. In 2015, 2016 was when we had the first really large mass bleaching event on the Great Barrier Reef. And so we didn't start with SRM as an idea. And we started just looking into all sorts of different ideas of how we might be able to basically shade or cool corals. And that led us over a period of time to look at marine cloud brightening. And as we did the desktop research and the engineering sort of feasibility evaluations, the marine cloud brightening just kept rising to the top of the pile while others fell out. So out of all of the ideas in cooling and shading, we've not dismissed a great deal. We've essentially prioritized, and so it's hard to dismiss things completely because we've had to prioritize the R&D effort, but we've certainly set aside some things that we think are less feasible. We can constantly run a sort of iterative prioritization process, and based on that, we've been focusing mostly on the marine cloud brightening and the seawater fogging, which is a much smaller scale idea to generate an artificial sea fog to shade small areas of coral, sort of high value sites. And we've also done research on some of the other ideas. So there's a few papers here and there, but the sort of prioritization processes led us to invest the most in those two ideas.
Daniel's group has conducted multiple campaigns since 2020, spraying sea salt aerosols from the back of a ship over the reef and measuring the cloud responses. As he noted, the main motivation for his group's experiments is to protect the Great Barrier Reef from high ocean temperatures, which can induce mass bleaching events. As David Keith noted earlier, all environmental food experiments come with some risks. What are some specific risks of the RRAP experiments to date? Here's Daniel Harrison again talking about their work over the Great Barrier Reef.
No, look, honestly, at the scale that we're doing them now, it would be untrue, I suppose, to say they don't pose any environmental risk at all. For example, the ship that we have out there could crash into a reef and cause an oil spill or cause damage to the Great Barrier Reef. So there's always risks. But in terms of sort of environmental risks from the small scale perturbation type experiments we're doing by actually atomizing seawater and releasing it into the atmosphere, I think they're sort of completely negligible. The greater risk would be an aircraft accident or a ship accident or something.
As we noted in our May 2025 episode about marine cloud brightening, an experiment that was similar to the RRAP experiments was cancelled in 2024. The University of Washington team that was running this experiment set out to spray small amounts of sea salt aerosols from a decommissioned aircraft carrier that had been converted to a public museum. However, the Alameda City Council, where the experiment was to take place, voted not to allow it over concerns about health and safety.
A group of scientists from the University of Washington's Marine Cloud Brightening program are mixing salt and water and using a compression system to test if this machine can distribute the right size particles. They say Alameda provides the perfect cloud conditions over the bay.
That was a news report from NBC Bay Area News on 5th April 2024. The test had begun on April 2nd, but in early May, the Alameda City Council asked the scientists to pause their test. Then, in a heated meeting on June 4th, the Alameda City Council voted unanimously to not allow the experiment to continue at all. This was just one of 3 relatively high-profile cancellations of SRM-related field experiments. In 2011, the field component of the Stratospheric Particle Injection for Climate Engineering, or SPICE, project in the UK cancelled its field experiment over conflict of interest concerns, when it came to light that 2 researchers involved stood to profit from the technology being tested. In 2021, a preliminary test flight planned as part of Harvard University's Stratospheric Controlled Perturbation Experiment, or SCOPEX, was cancelled. The SCOPEX team ultimately planned to add a small amount of aerosols to the stratosphere from a balloon. A propeller-driven gondola would have allowed the researchers to maneuver the balloon to measure the released aerosol particles' properties. What was the purpose of this, and how would the experiment have improved understanding of stratospheric aerosol injection, or SAI? Here's David Keith, who was one of the SCOPEX scientific leads.
Lots of questions you could answer with that kind of experimental framework. We were thinking especially about the coagulation of aerosols and about the reactivity of aerosols with, say, activation of chlorine species for ozone destruction, for example. Those are the 2 we thought about most obviously.
The SCOPEX field experiment depended on finding a high-altitude balloon operator, and there are not very many of those. The team originally planned to launch their instruments from Tucson, Arizona in the US, but there were complications with the balloon operators there. And after delays, the project moved to Kiruna, Sweden, where the team hoped to work with the Swedish Space Corporation. However, the project met with resistance, including objections from the Sami Council, the group that represents the indigenous Sami people of Finland, Russia, Norway, and Sweden. Members of the Sami Council were not available to talk to us for this episode, but Asa Larson-Blind, a Sami politician and then vice president of the Sami Council, spoke with Mark Turner, SRM 360's communications director, in 2022 when Mark worked at the Carnegie Climate Governance Initiative. Here's an excerpt of their recorded conversation.
In terms of your opposition, is it more to do with how this fit into the broader direction that humanity is taking on climate change, or were there any actual specific concerns you had about the experiment itself and the potential impacts of that experiment?
No, the experiment itself was very limited, and the experiment itself, I believe, without being a total expert on that, but I had not understood that would have had implications on the environment here. That was not the reason. The reason was that this was done or planned to be very clearly a part of developing this technology of solar geoengineering. And that idea is something that goes against what we believe is, from the Summit Council side, part of our chosen way forward, and not what we see is what we should be targeting and what we should be doing when it comes to combating climate change.
Opposition to the idea of SRM, rather than the environmental impact of the experiments themselves, also played a role in scuttling the 2024 marine cloud brightening experiment in Alameda, California. Why do some people believe outdoor SRM experiments need additional scrutiny? We spoke to Dr. Jan McDonald, Professor of Environmental and Climate Law at the University of Tasmania in Australia.
There is a concern that any form of outdoor testing will set us on a slippery slope, that once you allow one small activity, whether it's putting up one weather balloon or a million weather balloons, that once you've started to accept the legitimacy of this kind of research, that signals the acceptability of this intervention type. So for some, particularly in the environmental and climate community, there is resistance to any form of, not just outdoor testing. There are some who oppose modelling of solar radiation management effects and dynamics for those reasons, that it is a slippery slope and we should be focusing on the main game, which is emissions reduction. What we're seeing is that for the smaller scale outdoor experiments that are not necessarily focused on planetary scale in their intended application down the track, that there isn't necessarily the same opposition, there isn't necessarily the same discourse. So I think that the experiments whose ultimate objective might be planetary scale deployment are subject to a much higher level of scrutiny in the public discourse than those that might be at a smaller regional or local scale.
We also spoke with governance expert and executive director of the Alliance for Just Deliberation of Solar Engineering, Dr. Shuchi Talati.
I think SRM exists in a very different political context than a lot of other work. It's extremely controversial, as we've seen over the last couple decades of this field existing. And some of that is merited and some of it isn't, right? Some of it exists in a lot of misinformation and conspiracy. But there is a lot of potential for global impact, right? That's not something we've seen before in a lot of other types of climate technologies. When you look at something like carbon dioxide removal or even renewable energy, right? They are site-specific. The impacts of kind of the immediate direct impacts are felt in particular places, and the political dynamics are a little bit more separate. Something like SRM, that's a completely different context. This is something that will have global impact no matter what if it's used. And that political context is immensely complex. And whether or not we think that should be the case, it is the case.
We will hear more from Shuchi and Jan in an upcoming episode devoted entirely to research governance for SRM, a topic increasingly in the spotlight with the announcement of ARIA's new funding, which has made the UK the largest governmental backer of SRM research. That's it for today's episode of Climate Reflections. Thanks for listening. This is a new podcast and we're hoping to build our audience, so if you enjoyed it, please do share it on social media or recommend it to a friend. If you have a question about SRM or just want to find out more, go to our website, srm360.org. We answer questions from the audience in our monthly news roundup, so you might hear your question answered there. You can find a transcript of today's episode with links to sources on our website, so please check it out.